Good afternoon, students. Today we meet in this session of synchronous online class to continue our discussion yesterday on the module entitled Test of Hypothesis, which is the module given to you last module distribution. Actually, we have used two different sources this time. The first one is taken from the Division LRMDS module. And the second one is, remember the link that I have sent you that is taken from our DepEd Commons. Okay, so before we formally begin, let's start with the preliminaries of this session. By the way, class, if we are in the face-to-face classes, just like what we had last week, since this week is our schedule for the modular class, we have to always keep in mind the health protocol reminders, just like wearing our face masks properly, not just in the school, but in any other places where you've been through. But since you are in your individual or respective home learning spaces, I will just remind you to maintain the sanitation in your respective areas. So I hope that even if you are in your respective homes, you're able to wash your hands regularly with soap and water. So let's have our prayer. Checking of attendance. So I have monitored the attendance here in the list of those who have joined our Zoom meeting this time. So I have taken it down. Those who are not able to join may watch the recorded video so that they can still cope up with the discussion. So for this afternoon, the lesson objectives that we have are the following. Illustrate types of errors in hypothesis testing. Contribute meaningfully to class discussion by identifying their own questions about the given situation. Construct reasoning in real-life examples of committing type 1 and type 2 errors. And cite situation in a community that hypothesis testing is possible for type 1 and type 2 errors. Okay, are you now ready? Now this afternoon again, just like what I've mentioned earlier, we are going to discuss one lesson under the test of hypothesis, which is very tricky and very crucial to understand, is type 1 and type 2 errors. To review on the previous lesson that we have, I want you to provide the possible null and alternative hypothesis of the given scenario. Kyla, can you please read? Okay, thank you very much. Now, once again, I want you to read it on your own for 1 minute so that you can understand it more. Now, in the given scenario, the possible response, or let's have this one, our null and alternative hypothesis. The null hypothesis is the mean score of the incoming grade 11 students is 81, or in symbol, that is mean equal to 81. The mean score of the incoming grade 11 students is not 81, or in symbol, mean is not equal to 81. So I hope that you already master how are you going to write the null and alternative hypothesis. Now let us recall the null and alternative hypothesis by definition. Carlo, please read. The null hypothesis is an initial claim based on previous analysis, which the researcher tries to disprove, reject, or nullify. It shows no significant difference between the two parameters. It is denoted by that symbol. Sorry for that one, it's not properly stated, but it should have been written, the O must be placed as a subscript. Okay, I want to clarify. That is H with the subscript O. Okay. Then the alternative hypothesis is contrary to the null hypothesis, which shows that observations are the result of a real effect. It is denoted by H subscript A. Okay? Now let us read this another scenario that will connect us to our lesson for today. Now, Maria uses 5% level of significance in proving that there is no significant change in the average number of enrollees in the 10 sections for the last 2 years. It means that the chance that the null hypothesis would be rejected when it is true is 5%. Okay, review first the illustration. I know that you're familiar with that, but I want you to ignite your prior learning on what does the illustration signify. I will give you 1 minute for that. Kate, you're raising your hand. Yes. Yes, please. I want you to share your understanding on the given figure or illustration. Yes. Thank you very much, Kate, for giving me a very comprehensive response. That's correct. Now, in this figure, it's very clear that now in this portion, it's very evident that you can already identify the alpha. The shaded region there is 0.05. Now, it is actually the area under the normal curve within the rejection region. This is our rejection region. This is our acceptance region. Now, question number 1. What is the reason for having a 5% level of significance? This is still in connection with our discussion yesterday on the level of significance. What is the reason why we have level of significance in our research? Yes, Martin, you're raising your hand. You're now recognized. The level of significance, usually designated by alpha, this symbol, pertains to the degree of confidence we require to reject the null hypothesis in favor of the alternative hypothesis. Congratulations, Martin, for giving me a very comprehensive response. I know that you have really had your readings last night regarding our discussion for today. It is, again, the highest probability of committing a type 1 error. The next question. How do we decide whether to accept or reject our null hypothesis? Carla, you're raising your hand. You're now recognized. The decision on whether to accept or reject the hypothesis is based on statistics and not on hunches or opinions. That is, the difference must be significant. Therefore, if we accept the null hypothesis, even if the sample mean differs from the population mean, the difference is not significant at all. Good job, Carla, for giving me that answer. That is really the answer I am looking for. I hope that your classmates were able to understand the point of our discussion. I would like to make it clear. Thus, in question number 2, we say that they are statistically equal. This is where the ideas of statistical tests and level of significance are used. When one has formulated the hypothesis, the next step is to make a research design. So I believe your practical research teachers were able to incorporate this kind of discussion in your class. The researcher decides on the right statistical test and selects a fitting level of significance. Just like, for example, I want you to imagine this kind of this scenario. A sample of patients who will be given the vaccine will be chosen. You just have to think. Okay, then after they were chosen, after letting an appropriate period for the vaccine to be absorbed, the researcher will take each patient's temperature. Now let us remember that when samples of size n are carefully chosen from the population, again, we have this population, the general scope is a population, then we just have to get a sample out of the population because we cannot cater all. Okay, next, the means of these samples will differ from the population mean. So again, a sample is taken from the population, and then the means of these samples differ from the population mean, and the spread of these sample means will be nearly normal when the sample size is 30 or more. This is the standard number that we kept on using once we have examples. I have discussed this one last time. The size is 30, minimum of 30 or more. This means that that even if the null hypothesis is accepted, the mean of the temperature of the sample of patients will not, in most cases, be exactly equal to the population mean of 37 degrees Celsius. I hope that you were able to get the point. The clear point here is that it is not always an assurance that the result of the population mean is the same as the result to our sample mean. That is the very reason why we have placed hypothesis in the very first place. And that is also the reason why we have null and alternative hypothesis. I hope that you get the point here in this discussion before we proceed to the more crucial part of this lesson. Now, I am very excited to give this example because this is very timely and relevant to our current situation. Now, you decided, this is the scenario, you decided or asked by your superiors to get tested for COVID-19 based on mild symptoms just like coughing, having colds, sneezing. Okay, there are two possible errors that could potentially occur. Now, what are the two possible errors? First error, the test result says that you have coronavirus or COVID-19, but you actually don't. So again, the test result says that you have COVID, but you actually do not have it. Now, this is the type 1 error. We also call this one as false positive for us to easily understand it. This is false positive because the test result says that you have COVID, but you actually do not have. Now, the second possible error, the test result says that you don't have coronavirus, but you actually do. Again, the test result says that you don't have COVID, but you actually do. Now, this is now the type 2 error or the false negative. Again, it's false positive for type 1 error, false negative for type 2 error. Now, I want to ask you this question. Which do you think is better between the two situations? I want to hear from Carlo. Okay, thank you very much for your answer, Carlo. So for Carlo thinks that it is better to have the type 1 error because in reality, you don't actually have the COVID-19. So that is Carlo's stand on the question. But each of you can have your different answers. It's just a way of asking you because this is the lesson in which I am also requiring you to give your personal opinions since we are giving examples here that are also based on reality. Now, in testing a hypothesis, the researcher decides the level of significance, that is the very first place, to be used. Now, the gravity of type 1 error will be the basis for the level to be used. Now, in the figure earlier, you have seen the alpha portion. Now, that portion there, that is the probability of acquiring a type 1 error. Later on, I will be showing you the illustration. Where can we find the type 2 error? Okay? In statistics, a type 1 error is a false positive conclusion, while a type 2 error is a false negative conclusion. I hope that I made myself clear. Making a statistical decision always involves uncertainties, even in reality, even in our real lives. So the risk of making these errors are unavoidable in hypothesis testing. The probability of making a type 1 error is the significance level, or alpha. It is denoted by that symbol there. That symbol of alpha. While the probability of making a type 2 error is beta. This symbol, we're going to use at 1. This risk can be minimized through careful planning in your study design. Now, I want you to study the given illustration here, because later on I will be asking you to give your opinions and suggestion on how are you going to easily identify the region where alpha and beta belongs. Now, in this part, in this figure, just like similar to the figure shown earlier, this is the region of committing type 1 error. Okay? And this is the region of committing the type 2 error, or what we call the beta. The type 1 and type 2 error rates influence each other. That's because the significance level, or the type 1 error rate, we call the significance level as our type 1 error rate because we base also the decision of accepting or rejecting the null hypothesis according to the given significance of our given study. Affects the type 1 and type 2 error affects statistical power because they are inversely related to one another. The type 1 and type 2 error rate are connected. This means there's an important trade-off between the two types of error. Now, in setting a lower significance level, decreases a type 1 error risk, but increases a type 2 error risk. Okay, nakuha? Setting a lower significance level decreases the type 1 error risk. Kaya nga, sabi ko kanina, we are basing our type 1 error probability to the significance that we have placed in our study in the very beginning part of our research. Now, increasing the power of a test decreases a type 2 error risk, but increases a type 1 error risk. So, if we increase the type 1 error risk, it will decrease the type 2 error. And if you're going to also increase the type 2 error, then that will also decrease the type 1 error. Okay? I congratulate everyone who have given their inputs from the previous illustration shown. I believe that you were able to articulate it more when you are using your own dialect in sharing your ideas to your classmates. Now, to sum it up, this illustration here, or diagram, or table as we say, is the summary of the inputs taken from the previous illustration, or yung figure na ipinakita ko. Okay? Rejecting the null hypothesis, when it is true, is called a type 1 error. Again, rejecting the null hypothesis, when it is true, is called a type 1 error, with probability denoted by alpha. In symbol, that is the symbol. In hypothesis testing, the normal curve that shows a critical region is called the alpha region. Accepting the null hypothesis when it is false is called a type 2 error. Again, accepting the null hypothesis when it is false is called a type 2 error, with probability denoted by beta in this symbol. In hypothesis testing, the normal curve that shows the acceptance region is called the beta region. The larger the value of alpha, the smaller the value of beta. Again, the larger the value of alpha, the smaller the value of beta. Then vice versa. The larger the value of beta, the smaller the value of alpha. Okay? In order to understand more the context of these errors, I have given you another realistic scenario. This is the new scenario. You test whether a new drug intervention can alleviate symptoms of an autoimmune disease. So when we say autoimmune disease, it is a disease that is affecting your immune system. So if you're familiar with Chris Aquino, it is in the media actually, even until now, that she is having this kind of disease. She has an autoimmune disease. Now in this case, we have the null hypothesis. The null hypothesis is that the new drug has no effect on symptoms of the disease. So no effect. Now the alternative hypothesis is that the drug is effective for alleviating symptoms of the disease. This is our problem again, and these are our hypotheses, our null and alternative hypothesis. First question, explain what will happen if type 1 error occurred. Now I will be asking for volunteers, or if there will be no volunteer, I will call somebody to answer. But I want to remind you, class, that if you think your classmate is not correct, do not laugh. You just have to respect the response, because we do not have the same level of acquiring the gist of our lesson for today. Now, who would like to answer question number 1? Yes? Anthony, you were raising your hand. Type 1 error happens when you get false positive results. You conclude that the drug intervention improves symptoms when it actually did not. These improvements could have arisen from other random factors or measurement errors. Second question, explain what will happen if type 2 error occurred. Minda, you're raising your hand. A type 2 error happens when you get false negative results. You conclude that the drug intervention did not improve symptoms when it actually did. Your study may have missed key indicators of improvements or attributed any improvements to other factors instead. Okay, take note, class. A type 1 error means rejecting the null hypothesis when it's actually true. It means concluding that results are statistically significant when in reality they came about purely by chance or because of unrelated factors. A type 2 error means not rejecting the null hypothesis when it's actually false. This is not quite the same as accepting the null hypothesis, because hypothesis testing can only tell you whether to reject the null hypothesis. Now, meaning, instead, a type 2 error means failing to conclude there was an effect when there actually was. In reality, your study may not have had enough statistical power to detect an effect of a certain size. So again, I want to make it clear. Type 1 error means false positive, rejecting null hypothesis even if correct, even if tama ito. Now, the type 2 type of error is false negative, failing to reject or accept null hypothesis kahit mali. This time I have this scenario that is also relatable in my personal experience, since I have known someone who just opened a food cart business. Now, Brian is starting his own food cart business, and he is choosing cities where he will run his business. He wants to survey residents and test at 5% level of significance whether or not the demand is high enough to support his business before he applies for the necessary permits to operate in his selected city. He will only choose a city if there is strong evidence that the demand there is high enough. Now, in the given problem or scenario, the null hypothesis is the demand is high enough. Now, what would be the consequence of a type 1 error in this setting? would like to answer? Catherine, you were raising your hand. Correct. Very good, Catherine. The correct answer is the first statement. He does not choose a city where demand is actually high enough. That is a type 1 error. Next, what would be the consequence of a type 2 error in this setting? Peter, you're raising your hand. Yes, very good, Peter. He chooses a city where demand isn't actually high enough. Now, I believe that you are now able to understand the concept of committing type 1 and type 2 errors even if we applied those errors in our real life situation. Analyze the possibilities of Sophia's conclusion in the given problem. Identify if it is a type 1 error, type 2 error, or a correct decision. If Sophia finds out that her null hypothesis is, number 1, true and she fails to reject it, then she commits a, Karen? Exactly correct. Correct decision. Number 2, true and she rejects it, then she commits a, Carlo? Type 1 error. Exactly correct. Next, false and she fails to reject it, then she commits a, Kate. Answer? Oh, the correct answer is type 2 error. You answered type 1 error. So, I think, Kate, you are still in 90% level of understanding because sometimes we tend to get confused between the difference of the two. But I know that you are really working hard to get it right. But other than that, thank you very much, Kate. Number 4, false and she rejects it. Then she commits a, Martin? Exactly correct. Correct decision. So I appreciate your way of answering, class. You are confident enough. So I hope that even if this session ends, the lesson is still in your mind. You cannot forget that one easily because I believe that this lesson is still applicable when you reach your grade 12, when you already have your practical research too. Okay? Now, I will be giving you situations and let's try to choose the correct consequence once these errors happen in real life. Okay? Now, the direction is check the box that corresponds to your answer. Now, the first situation, a quality control expert wants to test the null hypothesis that an imported solar panel is an effective source of energy. Now, what would be the consequence of a type 1 error in this context? I want you to analyze. Delphine, you're raising your hand. Good job, Delphine. You were able to get the correct answer. The correct answer is, they do not conclude that the solar panel is effective when it is actually effective. Okay, that is type 1 error. Thank you very much. Number 2, what would be the consequence of a type 2 error? These are the choices. Karen? Exactly correct, Karen. They conclude that the solar panel is effective when it is not actually effective. That is the type 2 error. The next situation. A resort owner does a daily water quality test in their swimming pool. If the level of contaminants is too high, then he temporarily closes the pool to perform a water treatment. We can state the hypothesis for his test as, the null hypothesis is the water quality is acceptable. The alternative hypothesis is the water quality is not acceptable. What would be the consequence of a type 1 error in this setting? Correct, exactly. You're very good for giving me the accurate answer. Lauren, you were very active this time. The owner closes the pool when it does not need to be closed. Number 4, what would be the consequence of a type 2 error in this setting? Those are your choices. Okay, class, thank you very much for giving me the answer. The owner does not close the pool when it needs to be closed. But next time, I want you to give me the answer on your own. If you want to answer, you just have to raise your hand. You click the raise your hand button there on the lower portion of the screen so that you will be recognized. Do not answer me in chorus, okay? Now, the last question. In terms of safety, which error has more dangerous consequences in this setting? In this setting alone, ha? What do you think? Okay, I want you to answer me in chorus. I know, yes, some answered type 1 error, some answered type 2 error. But in this setting, it is more dangerous to have the type 2 error. Kasi the owner does not close the pool when it needs to be closed. It is somehow dangerous in terms of safety. But class, take note, for statisticians, a type 1 error is usually worse. In practical terms, however, either type of error could be worse depending on your research context. It still depends. But for statisticians, a type 1 error means mistakenly going against the main statistical assumption of a null hypothesis. This may lead to new policies, practices, or treatments that are inadequate or a waste of resources. But other than that, everyone, congratulations for giving me an active participation. Good job. Job well done, everyone. Now, what do you think are the consequences of committing type 1 or type 2 errors in real life? I want you to provide examples in reasoning. Parker, you're raising your hand. Oh, very good. I really appreciate you once you would like to share to the class because it only means that you are actively participating and so that you can also share to your classmates your personal experiences and insights regarding our lesson for today. Okay? Now, these are the examples of consequences of committing type 1 error. Now, based on the incorrect conclusion that the new drug intervention is effective, this is in connection with the given problem earlier in producing a drug that can cure an autoimmune disease. Now, based on the incorrect conclusion that the new drug intervention is effective, over 1 million patients are prescribed the medication. Despite risk of severe side effects and inadequate research on the outcomes, the consequences of this type 1 error also mean that other treatment options are rejected in favor of this intervention. Now, in contrast, in committing type 2 error means failing to reject a null hypothesis. It may only result in missed opportunities to innovate, but these can also have important practical consequences in reality. Now, the consequences of type 2 error is that the drug intervention is considered ineffective when it can actually improve symptoms of the disease. This means that a medication with important clinical significance doesn't reach a large number of patients who could tangibly benefit from it. So it is quite dangerous if you're going to place the errors in experimental types of research because it can actually contribute. It has a big contributing factor to our health and safety. Now, in this part of our lesson, we are already towards the end. I want you to check your learning. You check your learning on your own. Cite 5 situations in your community where you can apply hypothesis testing. Then, just choose one situation and do the following tasks. Create a problem statement, formulate the null and alternative hypothesis, select the level of significance and sketch the rejection region, and state the possible type 1 and type 2 errors. Now, if you belong in a certain area or even if you belong to a certain indigenous tribe or group, then you may cite examples that are relatable on you. Now, I will give you one example. Possible situations could be An Islam female student shares her experience in being married when she was still 13 years old. I have taken this example from my previous class with the same lesson. One student have shared that kind of scenario. And then you can also have the intelligence quotient of Bagobo male student is higher compared to their female learners. Okay, these additional activities is given to those students who were very quick in answering the previous activity so that there will be no dull moment on your part. Now, you have an option here to answer the additional activities on page 23 alone, or if you want to do it by pair or teams of 3 to 4 only. Do not have more than 4. Then fast learners, I know that you are already recognized before. I want you to pair with classmates who are still in the process of fully grasping the lesson in order to build a peer-to-peer dialogue and tutoring. Now, each team or pair must accomplish the task and present their draft within the period. You may send it to me through Facebook Messenger, or you may email it to me in the given email address in the chat box. The draft only, and provide the final output next meeting when we already meet face to face. Okay? Now, the additional activity, you may look into your module in page 23. The criteria is shown here. Peer dialogue with proof of communication is given 15 points. And the draft is given also 15 points with a total of 30 points. Any question? So if you have any point of clarification, you may just message me later, or you may ask your questions in the chat box. So I hope that you were able to get some input on our lesson for today. This video is recorded. You may watch this video again later if you would like to recap or to point out a certain discussion that you are not yet that you did not fully understand yet. Okay, I will be expecting for your draft to be sent within the period end.